Hi everyone, my name is Marco Cagna. I'm a product manager with AWS Global Accelerator, a new service launched at reInvent 2018. Today we're going to talk about how you can improve your application's availability and performance with AWS Global Accelerator. The goal for you today is really to learn about how to improve your availability by routing traffic across AWS regions, how to accelerate your global latency-sensitive applications and mission-critical applications, and really learn more about the Global Accelerator architecture and how we look at different global services like CloudFront or Route 53 versus Global Accelerator in different use cases. First, we will cover what a Global Accelerator is, its benefits, how it works. We'll look into how you can leverage this service to architect for high availability. And then we'll walk through the console of Global Accelerator and do a quick demo showing its capabilities. So as I mentioned, AWS Global Accelerator is a new service meant to improve the availability and performance of your applications for global end users using the AWS Global Network. So really, you'll benefit from the service if your users are distributed across multiple geographies, and really you will benefit from having your user traffic onboarding and traversing the AWS Global Network for the majority of the time. So let's start from a simple use case in which you have your sample application running in an AWS region. This application might have an application load balancer fronting a number of EC2 instances and network load balancer. You may want to have your users going directly to an EC2 instance. And really, you have users that are trying to access via the public internet your applications in the region. And so the biggest unknown here is that white cloud, which is the internet between your users and your application. So let's say that you have a few local users connecting to your application. Let's say your users are in North America and your application is hosted in US East 1. It's a good scenario from a latency perspective. Let's say that your application becomes more popular now, and your users start becoming more and connecting from multiple places around the world. Now it takes about 100 milliseconds from Europe to US East 1. You may have to do multiple round trips. And so you can tell from just how the internet operates that the further away your users are going to be from your application in the AWS region, the higher latency they will experience. Especially if they could connect, they can connect directly to the single deployment in, let's say, US East 1. So you may want to do is you want to deploy your application in multiple AWS regions. And run it in in an active mode when the same application is running basically in the same way for multiple locations. Let's say you have one in US East 1, one in Frankfurt in US Central 1, and one in Asia Pacific Southeast 1. Now, what you may want to do here is have multiple you have DNS. You may want to use DNS to be able to resolve and associate your domain name to your multiple regional applications. And your regional applications are going to have different IP addresses for the load balancers and the EC2 instances in it. So what happens today, for example, for a user in Seattle, is that he queries a DNS resolver for www.example.com, and he gets back the based on latency-based routing via, for example, Route 53, you will get the IP address of the closest application to users in Seattle, which in this case is US East 1. your users' client devices might cache that IP address. So you might incur in the case in which, for whatever reason, the application is not reachable anymore, is not healthy anymore in USS1, and your and your user still is caching that IP address. And so now when the user makes another DNS query, it gets actually the IP address of the next healthy application, which is in US Central 1. But the cache might still say that the endpoint they should reach out to is in USS 1. And so you may have this disconnect. And even if you solve this issue of having client caching for long times, you still face the challenge in this situation that user traffic traverses the public internet to reach those regions around the world. So some of the challenges that we observe AWS customers having and that led us to build Global Accelerator, as I mentioned, the first one is that IP caches in client applications can be unreliable. The second is that routing over the public internet can lead to inconsistent performance. So you may have spikes in latency, availability drops based on internet weather events around the world. And the third one is that the more applications you have around the world in AWS regions, and the more components you have, the more IP addresses you need to manage and configure and whitelist in your client devices. And this can be cumbersome to manage. And so we build Global Accelerator as a network layer service that help you solve some of these challenges. So you can deploy the service in front of your internet-facing applications running in the AWS regions to improve the availability and performance for your globally distributed users. So it sits in between the client devices, so your users, and the AWS applications running in the region. We'll dive into these benefits, but at a high level, you get improved availability, improved performance, and ease of use in managing IP addresses. So far, we've been seeing good response from our customers, and really Global Accelerator provides value for any use case you might have that is critical and latency sensitive. And so we've been seeing customers from digital publishing, mobile applications, media, entertainment, Internet of Things, advertising technology, and financial services. And you may see yourself reflected in some of what we're going to discuss in the upcoming slides. So one use case is, for example, real-time gaming, when where you have game servers running in multiple regions, you have players connecting from all over the world from different regions, let's say North America, Europe, Asia Pacific, and you require consistent performance independently of where the user is connecting from and your gamers are playing from. And excessive latency can lead to an undesirable experience for each gamer, especially in multiplayer games. Another example of a applicable use case is payment transactions, in which any downtime can lead to loss in revenues, and you may face this unpredictability of IP caching by client devices, which during a transaction might point to an endpoint or an application that is not healthy at the moment, hence incurring in downtime for your application. And in this case, what you're looking for is instantaneous failover in between your applications in different regions, and fast change propagation, what we call change propagation. The final use case we are highlighting here is in case you have a digital security and threat intelligence app in which you need to whitelist IP addresses in your security applications that may be spread in devices around the world. These IP addresses change as the application scales up or down, and you need to add EC2 instances and load balancers and this might compromise the security by whitelisting an IP range that might not be healthy anymore. And so here, what you're looking for is a small set of static IP addresses that you can hand over to your devices and your application and your security applications around the world, so that it becomes really easy for you to manage anything that is behind the static IP addresses without having to change anything in your client front end. So let's look at some of the key features of AWS Global Accelerator. The first one is that once you create an accelerator, you get handed 2 static IP addresses. These are IPv4 addresses today. And these don't change for the life of your accelerator. So as long as you don't go and delete your accelerator, those IP addresses are with you, and they are static, and you can use them to front your applications in different regions. Here you see the word anycast, so we'll talk about it later, but the idea is that these IP addresses are anycast and announced from multiple AWS edge locations. So these are the many edge locations that our AWS Global Network has around the world. Second key feature is intelligent traffic distribution. So you will see that you have control on how traffic is distributed across multiple regions and across your application endpoints in a single region. But what Global Accelerator does by default is that it directs users to the closest edge location, and from there to the closest healthy region, so that wherever your application is running. And you have some controls that we'll look at later. Enhanced fault tolerance, this by default comes with Global Accelerator, and we'll talk about it later, but the idea is that you have these 2 IP addresses, the static IP addresses that you can hand over to your clients come from different, what we call network zones, so different private infrastructure, different subnets, and they're announced to different carriers. And so really, if there is any form of failure on one, you get your client to retry on the other one, and the fault can be isolated to only one of the 2. Global Accelerator supports 2 protocols that are TCP and UDP. You can run any kind of application above that. We do instant region failover. So if you set up 2 regions accepting traffic, and all the endpoints in one region become unhealthy, within a minute we shift traffic to the next available healthy region. And finally, we support application load balancers, network load balancers, and elastic IP endpoints in the backend. So I'll include here one of the most frequently asked questions from our customers, which is, how is AWS Global Accelerator different from Amazon CloudFront, the content delivery network of AWS? So Amazon CloudFront is really targeted at HTTP and HTTPS use cases where your content is cacheable, or you want to proxy your content towards your origins. And this can be S3 origins, this can be custom origin, or EC2 instances. And really you benefit in this case if your content is first cacheable, so for example static content like video or images, or if it's dynamic but it's primarily a HTTP use case. And it uses a set of changing IP addresses behind the DNS name, so you still incur the IP caching, the long duration of IP caching that we talked about earlier. AWS Global Accelerator can run a wide range of applications over both TCP and UDP. So it really helps if you have multiple endpoints in different AWS regions and you want to front them with this single static IP address. The second question we get a lot is, how is AWS Global Accelerator different from DNS-based traffic management solutions that are out there? So these solutions usually run into the issue that client devices cache the answers for long durations. So it is hard to know how long it will take before these users have the updated, most recent IP address pointing to a healthy application. With Global Accelerator, you get these two static IP addresses so that you avoid having to rely on IP caching settings on your devices, the client devices. And you have no need to update the DNS configuration anytime something moves in your backend across regions or availability zones. So let's dive into the availability benefit here. So the benefit of having these static anycast IP addresses is that today, once you get an IP address from AWS Global Accelerator, you can include it in your A records, in your DNS, like Route 53. And that's what the user will always get, the client device will always get. And so these IP addresses are advertised from multiple AWS edge locations around the world. So users can connect basically via anycast to the closest edge location, and then they are directed by Global Accelerator to the closest region to them where your application is running, with no client change required. So if an health check fails in one of the regions, let's say in Southeast Asia, your Global Accelerator will detect it via health checks, and a few seconds later, it will route traffic to around the fail endpoint to the next healthy available endpoint running on AWS. In terms of performance, AWS Global Accelerator really lives at the edge of the AWS global network. As we mentioned, we have these addresses that are yours, belong to your accelerator. They are announced from multiple edge locations. Your users connect to the closest edge location, and then from there to the closest region to them. This helps by minimizing the time and space that your user traffic runs over the public internet. So minimize the possible internet weather events that you may face on the public internet, and ensure a more consistent performance for your users. The benefits of running on the global network is really that it's a highly secure network. So traffic traverses our infrastructure rather than the public internet. It's highly available. We control the scaling and redundancy of capacity. We have redundant private capacity between all regions, and it offers reliable performance. It is a jitter-free, congestion-free network that AWS controls, and AWS controls really the path that the customer traffic traverses. So it is fully managed and monitored by AWS. So this is another way to show you that without Global Accelerator, your user traffic will traverse multiple service providers to get to the AWS regions. With Global Accelerator, that the span where the traffic traverses the public internet is reduced. User traffic is onboarded into the AWS global network as close to the client as possible, and this results in improved quality of service for your users. Now, how is the optimal endpoint selected? So how is your user directed to the best endpoint for them? So there are different aspects here. The first one is that Global Accelerator looks at the application's health. So there are continuous health checks to your endpoint in the AWS regions. The second aspect is geo-proximity. So users are directed to the closest regional endpoint to their location. There are some policies that you can configure in terms of to what region traffic should be routed, and within a region to which endpoint it should be routed. And finally, there is this aspect where you can set client affinity so that the same endpoint will always be the same client will always be directed to the same endpoint in your backend. So by definition, by default, your client get directed to an endpoint based on this 5-tuple, which is a combination of the protocol, the source IP, the source port, the destination IP, and the destination port. That's how Global Accelerator selects the optimal region for your client. And then we hash this 5-tuple and make sure that it goes, to a region, and then it's distributed evenly across endpoints in the same region. Now, for some use cases, for example, video ingestion, you might want to have a 2-tuple. So you may want to have the same client going to the same endpoint independently on the port and the protocol where the traffic is going. So in the video ingestion example, there are different streams for video and audio coming from the same client but from different ports. And you may want to send them to the same processing server in your application. In this case, you can enable client affinity in your accelerator, and Global Accelerator will start following this pattern. The last benefit is ease of use. So as I mentioned, when you configure an accelerator, you create one, you get assigned to a static IP addresses. Behind these, you can put multiple listeners. So in the console, you create an accelerator. Once you created one, you can create multiple listeners. A listener can be a TCP or UDP listener, and you can really define the port ranges that fit your use case. In this case, let's say you have 2 listeners, one on port 80 and 443, and the other one a UDP one on port 53. Behind each listener, you can create multiple endpoint groups. You can create one endpoint group per region, so this is really tied to a single region. So you can have, for example, 3 endpoint groups, one in 2 in the US and 1 in Europe, for example. And within each endpoint group, you can include multiple endpoints, and this can be application load balancers, network load balancers, or elastic IPs. Now, I mentioned earlier that there are some controls that you have on where the traffic is distributed. So we have this concept of traffic dials that you can set at the regional level. So by default, these traffic dials are 100%, and this means that all the traffic that is directed to a specific region will be accepted by your applications in the region. So if you want, for example, to stop sending traffic to a particular region, you can set the traffic dial to 0, and Global Accelerator will detect the change and start shifting traffic away from that. And they might be useful for stack upgrades or any kind of maintenance that you want to do on an application, or simply you want to route away traffic from the region. So once you go and set a traffic of dial of 0, we'll start steering away traffic from the region. The second control that you have is endpoint weights. So once traffic lands on a region, you can decide how the traffic is distributed across multiple endpoints. So in the first case, you're basically saying that you should go 50% to the first endpoint and 50% to the second one. So the minimum will be 0, the maximum to 55. If the default is 128, so half of the traffic should go there. And the second region, US West 1, in this case, you're saying that 25% of the traffic should go to the first endpoint and 75% to the second one. And this is a granular fine control that you have, and may allow you to do A/B testing or application stack migrations, for example. So really the benefit of having a fixed entry point is that, let's say you have deployments in multiple regions and multiple availability zones, and in each region, you want to put an accelerator in front of them. You get the static IPs that you give to your clients, and really you can operate a multi-region deployment behind it. And in case you want to add a deployment to another region, you don't really have to change anything on your client configuration, IP configuration, or DNS records. So how fixed IPs, the static IP addresses help is that really you don't need to make any client-facing changes in case of migration between endpoint types, whitelisting of IP addresses in security applications, when you want to scale applications to new regions or availability zones, or any stack upgrade, a software upgrade on your application. Let's now look at how to architect for high availability with Global Accelerator. So you can really strengthen your availability posture with Global Accelerator in multiple ways. The first one, as we mentioned, is the network zones. I'll describe that in a second. The continuous health checks that Global Accelerator uses. These are basically RAW53 health checks that we ingest or you can create via Global Accelerator. The traffic that flows through Global Accelerator and is processed by it is also processed by AWS Shield, so our managed DDoS protection service at the edge, and you get the benefit of having your traffic going over the secure and highly redundant AWS Global Network. So I mentioned this concept of network zones. So when you get these two IP addresses, they are advertised from multiple edge locations. These IP addresses belong to different subnets, belong to different physical infrastructure, and they are advertised to different carriers. So in this case, you see how you may have you have two zones, and your clients always see both IP addresses, but these may be announced by different physical infrastructure and different subnets. So during the failure of an edge location on one network zones, you really have clients always being able to retry on a healthy IP address that is supported by another network zone. And so what you really want to do as a best practice is to hand out both of your traffic, both of your static global IPs to clients at the same time, so that both have records in DNS in DNS can have both. So we have also a cellular architecture. This is really a way for us to be able to provide customer isolation. So customers will be associated to, will be able to have two IPs from two different network zones, and then be associated to different cells, so that we really minimize. In this case, you see we have multiple clients, and they might overlap in cell C, network zone B, but on the other one being actually spread into different cells, which means that you really protect yourself from noisy neighbors, where a failure from one client application, one application, and on one specific cell in one network zone doesn't impact many of our customers. Health checks. I mentioned before, we ingest health checks that you previously created on RAW53 from your ALB and NLB endpoints. You can configure new health checks for Elastic IPs endpoints, and we support any health check that is TCP, HTTP, and HTTPS, but you can configure the port, the interval, and threshold. I think it's the minimum interval today is 10 seconds. So in this case, Global Accelerator uses the health checks that you set to detect that, let's say, there's an issue in one endpoint, in one availability zone in a region, in which case it will route traffic to the next healthy endpoint in the same region. And in a case in which really application in one region are unhealthy. Global Accelerator will shift traffic to the next, fully to the next region. DDoS protection, as I mentioned, all the traffic that flows through Global Accelerator is protected by AWS Shield, the managed DDoS protection service that AWS offers, that really protects you from traffic that is not your user's traffic and potential DDoS attacks. You can also opt for using AWS Shield Advanced that allows you for increased protection from DDoS attacks and be able to work with the DDoS response team on how to best react to potential DDoS attacks. And really, so far we talk about how the Global Accelerator works well for multiple region deployments. Really, even if you have a single region application with clients connecting from multiple geographical areas, you want to enhance the performance and reduce latency for them. Global Accelerator will work for you because you onboard traffic as soon as possible into the AWS Global Network. You can give static IP addresses to all your clients, and you can scale applications behind them seamlessly to your clients. For visibility monitoring, Global Accelerator offers flow logs, which are very similar for those of you who are familiar with it to the VPC flow logs. And the type of information that you find in those is the client IP address, the client port, the endpoint region, IPs and port, and really a view of all the packets coming in and out, and the bytes that come in and out over a certain period of time. So we wanted to go through quickly how the console experience looks like. So in the AWS console, you find the Global Accelerator under networking and content delivery. You click on it, this is the experience. You get an overview of how it works, different benefits and features, some of the use cases that we recommend looking into, and services that are tied to it. And on the right, you find some useful resources like the developer guide. To create an accelerator, you click on Create Accelerator. On the left-hand side, you see all the steps that you should follow to create one. It should be really quick. Here, we're giving a name to it, and in this case, you select IPv4 as the address types, the static IP addresses that you will get. Press Next. Here we create listeners. As I mentioned, this can be on multiple ports that you want to set. It can be a TCP or UDP protocol. You can set client affinity. I'm not going to set it right now, but it's the option to direct traffic always to the same endpoint, dependently on the port. You can create, again, multiple listeners. In this case, we're diving into a single listener that we just created and adding multiple endpoint groups. So we can create one endpoint group per region. So the first aspect that we need to select is which region you want it to be. In this case, I'm selecting US 1. You can configure health checks. And by default, the traffic dial is set at 100. I'm not picking a second region. In this case, in Frankfurt, the EU Central one with the same setup. And now I'm going to add endpoints to each of those. So in US 1, I'm adding basically an elastic IP address associated to an instance. You need to give the EIP allocation ID. You can set the weight. In this case, is 100. It's the only endpoint I'm adding. And I'm adding another elastic IP address associated to another instance in EU Central 1. And it's really to create an accelerator. Now you'll see that the status is in progress. and so will turn into deployed. Once it's deployed, then it can really start serving traffic. So now I'd like to show a demo of the intelligent routing capability that I talked earlier. So in this case, already creating an accelerator. You can see the details here. I created one listener inside it with protocol TCP and port 80 and 443. Inside the listener, I created two endpoint groups, one in US Central 1 and one in US East 1. Within each endpoint, I created an elastic IP endpoint type, and this elastic IP is associated to an EC2 instance running in the region. You see these two static IP addresses. Now I'm going to use them. I've used them for and associated in the A record of my associated with my domain name from my website. Here's the website and domain name hosted in Route 53. I go into record set, and you can see I created an IPv4 A records with the two static IPs that Global Accelerator provided me. Now if I log into the instance in USS 1 and I curve from my domain name, I see that the application replies from USS 1. It's a simple application that replies with one line. I exit SSH into the instance in US Central 1. I try to curve my domain name, and I see that the application is answering basically aligned with US Central 1. Now what I want to show is that from Seattle, I should be directed to the closest application, which is running in US East 1. But if I go and stop the instance in US East 1, I should be redirected to the next available one, which is in US Central 1. So if I go in the browser from here in Seattle, and I query from my domain, you see that the application is responding from US Central 1. This is because Global Accelerator routed traffic away from US East 1 and directed it to US Central 1. Now I wanted to quickly touch on pricing. So the pricing of AWS Global Accelerator is composed of two dimensions. The first one is a fixed fee of $0.025 for every hour or partial hour that your application runs. And this really means that for every accelerator that you have deployed in your account, whether it's enabled or disabled, you're incurring into this fixed fee. The second dimension is what we call data transfer premium. So this is a per gigabyte rate that you fee that you get charged for the traffic that is processed by Global Accelerator. This is on top of the EC2 data transfer rates that you pay today, and you'll find them in the EC2 pricing page for on demand. This data transfer is charged in what we call the dominant direction. So for every hour, we look at all the traffic coming inbound from your users via Global Accelerator to your applications in the region, and the traffic outbound from the regions via Global Accelerator to your clients. We look at the maximum of the two, and the dominant is this one, is the maximum of the two, and we charge you for the dominant one, and we drop the other one. So if in an hour we observe that you do more outbound traffic, we charge you for that, and you don't pay for the inbound one. And it's really these fees are depending on the source destination region, geographic area pair. So you will see a table number pricing page that looks at your source region in North America, Europe, and Asia Pacific, and the destination where your clients reside, again in North America, Europe, and Asia Pacific. And there are different rates for these combinations. It's really, the main benefit is a pay-as-you-go, pay only for what you use service. And I'll encourage you to go check out the pricing page. So in conclusion, what this means for you is that Global Accelerator helps you create a more robust, highly available, highly performant architecture, increases the stability of your network and the performance and consistency in performance for your users. It provides automatic health checking and intelligent routing. It provides these static anycast IPs that you can give your clients. It leverages the AWS Global Network, which is congestion-free, jitter-free, and fully managed by AWS. And it leverages the health checking capabilities that AWS built over the years. All right. That's all from my side. Thank you. Hope it was useful. And to the next one.